Do the square roots of negative numbers exist in the reals? A real number is either positive or negative, and squaring either of them always gives us a positive number. Which doesn't mean that the square root of negative numbers don't exist at all. They just don't exist in a set of real numbers. Just like how the reciprocal of 2, a natural number, is not a natural number, but a rational number. The square roots of negative numbers live in a set of imaginary numbers, which revolve around the square root of negative 1, denoted by I. Multiplying it by a real number allows us to express the square roots of other negative numbers. It turns out we can expand even further and create yet another class of numbers by simply adding a real number, say a, to an imaginary number, say bi. This composite number, a plus bi, is called a complex number, and a is known as the real part and b is known as the imaginary part. Is there any way to plot these complex numbers? Complex number has two parts, and hence we need two dimensions to plot it. We can think of the coordinate plane, but we replace the x-axis with the real axis and the y-axis with the imaginary axis, labeled with the multiples of I. Real and imaginary numbers lie on the respective axes, and other complex numbers lie elsewhere on the plane. Hence, every complex number represents a certain distance, which is absolute value from 0 on a two-dimensional plane. Complex numbers can be compactly described to the transformations and rotations, which is why they reach quantum mechanics and electrical analysis. For example, it turns out multiplying any complex number by I simply rotates the number 90 degrees counterclockwise about the origin. The general picture, the geometric effect of multiplying any two complex numbers with each other, is understood by representing the parts of the complex number using its absolute value and the angle it makes with the positive real axis.